All right, hello everyone. My name is Kevin and I'm here with Barbara. Together we both like to welcome you all to our latest Novedge webinar series episode. For this week's webinar, we're teaming with Solid Edge technical consultant Kevin Grayson and give you a first-hand look at Solid Edge with Synchronous Technology for design engineering. Solid Edge with Synchronous Technology offers design engineers a new, groundbreaking way to design faster with more flexibility. Whether your design consists of brand new parts being modeled from scratch or you're repurposing existing data. Be it Solid Edge Classic or Solid Edge Foundation, Synchronous Technology removes traditional design constraints and allows you to get your products to market faster. For those of you who don't know who our presenter is, Kevin Grayson is a technical consultant and application engineer in the Siemens Channel Enablement group and has more than 13 years of experience with Solid Edge. Kevin works closely with Siemens Channel Partners as well as the direct Siemens sales team, helping sales and technical personnel strategize ways to get Solid Edge into the hands of new customers. He's also worked as a Solid Edge certified instructor and has trained hundreds of Solid Edge customers. Kevin, if you're wondering where Kevin's background is, he has a bachelor's degree in mechanical engineering from the University of Cincinnati. Today's presentation is about 40 minutes long, and afterwards we'll have a brief Q&A where Kevin will answer your questions live. So submit yours to us at any time into the chat window below. But before we get going with today's presentation, here's an overview of what we do at Novedge. The Novedge webinar series is brought to you by Novedge.com. As one of the largest online design software stores, we offer a huge assortment of software solutions that cater to virtually every designer's need. If you're looking to learn more about Solid Edge, you are welcome to call and speak with our specialist, Calvin Locke. Of course, you can always email him at calvin@novedge.com. Barbara, I think you have a few things you want to mention as well.
Yes, I'm here to strongly encourage you to visit the Novedge blog to get a glimpse at who is changing the world of design one step at a time. Meet the innovators, the makers, the architects, the VFX artists who work right on the edge of creativity and technology. Great interviews, great images, and great stories. Come visit us today at blog.novedge.com. And to catch up with the latest product promos and Novedge webinars, like us on Facebook, another source of endless information. Coming up next week, how well does Maxwell Render's plugin perform in an actual design workflow? Working architect Francois Verhoeven joins us to demonstrate the modeling and visualization process with SketchUp 2014 and Maxwell Render Suite V3. Using examples from a real-world project, you can see it for yourself and see why Maxwell Render is the premier choice for architectural previews and renderings in SketchUp. The presentation is free and will last about 1 hour, including the Q&A session. To sign up, head on over to www.novedge.com/webinar/113. Last but not least, today's webinar is being recorded live. If you want to rewatch episode 112 in its entirety, as always, you can find it on our Novedge webinar series channel through Vimeo and YouTube. And now I leave the microphone to the two Kevins.
All right. Well, I guess I'm Kevin 1, and Kevin Grayson, the smarter one, is over there in Cincinnati. So, Kevin, are you ready? Kevin?
I'm ready.
Cool. Awesome.
Yes, I'm ready.
So I'm going to pass the mic and the podium to you right about now. Everybody, enjoy.
Thanks, Kevin. I really appreciate this. And thanks, everybody, for attending today, either live or if you're watching this on replay. Before we get into the presentation itself on what Solid Edge is and how Synchronous Technology can help you with design iterations and design parameter type applications, I wanted to tell you a little bit about what Solid Edge is in general. So hopefully in the future we'll be able to have some additional webinars on some of these other applications, but what exactly is Solid Edge for those of you who may not be familiar? So Solid Edge is a complete design solution. What we're going to be focusing on today is Synchronous Technology. And this is going to be an application that's going to allow you to design very quickly, whether you're designing natively in Solid Edge or working with data from other CAD applications. The Synchronous Technology application is something that's going to be very easy to use and allow you to design very flexibly. Other things that we're able to do in Solid Edge is we can import 2D and 3D data from other sources and make modifications to those. We can also do other types of digital prototyping for your design needs, whether you're doing routing, frame design, or any other type of application that's common to engineering. We consider ourselves the best in the sheet metal application. We've had very great and very robust tools in sheet metal industry and allow you to design those types of applications very quickly. We also pride ourselves in working with massive assemblies. So, and obviously that term is very relative depending on what you do. Some companies may consider a massive assembly 50 parts, but others are going to consider thousands and thousands of parts a massive assembly. And we have a lot of great tools built inside of Solid Edge to handle those types of assemblies as well. Automatic drawing creation. It's great to document your design in 3D, but what about the 2D drawing documentation? So once we have our 3D models, our 3D design in place, creating the 2D documentation for those is very, very easy to do. So whether you're just trying to extract different views or get a bill of materials as an example, we create that type of documentation very seamlessly. Collaboration. We have a lot of great collaboration tools, whether you're collaborating internally within your company with sales or marketing, or externally with customers or vendors. A lot of built-in tools for collaboration as well. Simulation. Whether it's motion simulation or doing finite element analysis, we have a lot of great built-in tools that allow you to test your products, test your design, see where maybe some points of stress are going to be applied to your parts. We allow you to validate those inside of the CAD solution automatically, get those results out, and allow you to do that before you start making parts. And then finally, being able to manage all of this data. We have a lot of great data management tools for Solid Edge as well. And what we're going to do in the next 30 to 40 minutes is talk a little bit about Solid Edge and how it can help you design better. Before we get started with Synchronous Technology, for those of you who may not be as familiar with the CAD industry as a whole, I wanted to introduce you to some terminology and just talk a little bit about how Solid Edge differentiates itself from some of the other CAD products out there on the market today. I'm going to talk a little bit about history-based modeling. I may also refer to that during the presentation as traditional modeling, but typically in history-based modeling, the designer is going to be spending a lot of time creating 2D sketch geometry, applying what they call constraints and dimensional information to the 2D underlying sketch. And essentially in constructing the 3D part model, the model is, if you were to look under the hood per se of how a 3D model is constructed with this history-based modeling approach, it's going to look something like what you see down here in the lower right-hand corner, where you have all of these different 2D sketches, constraint systems, and dimensions on the 2D sketches, which make up the 3D model. Some of the drawbacks to this type of application is the model has so much dependency or reliability on those underlying 2D sketches to where when changes need to be made, it's not so easily done unless a lot of pre-planning has been done onto how that part should have been modeled. And what we're going to try to do today is talk a little bit about some tools that are built inside of Solid Edge that make this process a little bit easier. Some other things that you'll notice too in a history-based modeling approach is once the model is complete, or even during the design stage itself, is obviously changes are going to be happening throughout the process. We may start off with one idea, but then change our minds onto how something should be designed. So anytime in this history-based modeling approach we need to go back and make changes, we're essentially going back into how the part was designed in the first place and making those changes per how it was designed. And there could be some limitations into that, where if I make a change to one of the features in my model that was done in the early stages of the design process, it could inherently infect things that happened downstream, and I could end up with some errors in my model. So because of this approach, again, it's not very easy to make certain types of design changes. And hopefully in the next demonstration that we show you, we'll show you with Synchronous Technology, these types of design changes are going to be able to be executed very easily. Again, I just want to give you a quick preview of what we're going to be talking about today. Again, because of our time limitations, we're not going to go into a ton of depth, but I wanted to talk, first of all, how we're going to design natively inside of Solid Edge and building a component inside of an assembly utilizing what we call this region approach. We create sketch geometry very similar to other history-based applications, but once we have the 2D sketch geometry, what we're able to do with it after the fact is going to be some very powerful applications. So we're able to not only apply the dimensions to the 2D sketch, but those 2D dimensions are automatically going to apply themselves to the 3D model. So we do that so that the user is going to have a lot more direct interaction with the model itself and not spending so much time working on the underlying 2D sketches. So I'm going to show you this approach first. From there, what we're going to do is talk a little bit about how synchronous technology can help you make revisions much faster. And we're going to go through a scenario where we import in some geometry from another CAD system and make some changes to it. And we're going to talk in that section a little bit more about some of our editing tools. As a more generic term, we have what we call grab-and-go tools. Internally within Solid Edge, we call it our steering wheel tool, and allows us to make edits directly on the geometry. We also have a tool built inside of Synchronous Technology called Live Rules, which allows us to automatically capture the design intent of the model, and it'll make changes very quickly to the part. And again, we'll talk a little bit about how we can apply dimensions directly to the solid model versus the 2D sketch, and how that makes making those changes very quick as well. So basically, using synchronous technology to revise parts faster, again, the bottom line is going to save your company a lot of money. And then the last thing we'll talk about is better reuse. Reusing data, whether it's legacy data from our company or whether we're bringing in data from maybe a vendor or a supplier, or maybe something we found out there on the web, and being able to utilize documentation that was not designed natively inside of Solid Edge. What can we do with it? How can we repurpose what we have into something that we may need downstream? From here, I'm going to go ahead and get right into Solid Edge. And again, I'm anticipating that the audience today is categorized maybe into 3 different groups. Maybe the first group would be those users or those audience members who aren't really familiar with 3D CAD in general. And for you, I would say enjoy the presentation and learn a little bit about what you can do inside of a 3D modeling application. The second group may be those of you who are utilizing a history-based CAD design tool. And what I would ask you to do during this presentation is, as we're going through different scenarios, maybe ask yourself, how would I do that today in my design tool? How would I do what he just did with the tool that I'm using today? And then the third group of people may be those of you who are using Solid Edge today. And what I would ask you to do is take a look at what we're showing. Ask yourself, was I aware that that tool is available to me? And we'll go from there. What we're going to do is we're going to utilize this particular data set. It's a racing motorcycle. This was designed by a group of engineers from Polytechnical College of San Sebastian, which is located in Spain. And they were given the task to design and fabricate a prototype of a 125cc two-stroke racing motorcycle. And they did very well with this design and this prototype, and I thought we would utilize it to share some of the tools that we have today inside of Synchronous Technology. The first thing I want to draw your attention to is the interface of Solid Edge and how it is very Windows-based or Windows-focused. So we utilize the same types of applications. If you're familiar with Microsoft Word or Excel, basically we have the ribbon approach to the user interface, where we have the different tabs that run across the top, and then the ribbon, which contains different command tools that are available to you. We also have the application button, where you can get access to open or save documents and get access to different options that you can set up. And then over here on the left-hand side, this is what we call our Pathfinder inside of Solid Edge. Gives you access to the parts that you've designed so far. So obviously in an assembly like this motorcycle, we have different components that we may want to work on. For those of you who may be familiar with 2D CAD, there are companies out there who do 2D only type applications where you're basically just drawing on a flat sheet of paper per se, but you're doing it digitally inside of your computer. Those types of applications have a tool called layers where you may want to turn on and off different parts of your 2D sketches per se. And we have the same type of application here in Solid Edge with what we call design configurations. So in a motorcycle like this, I may only want to look at the frame and not anything else. So you'll notice I can turn off the outer shell or other components of the motorcycle very quickly just by tagging that I want to look at the frame. My design task in this example is to model a new part closer to the front of the motorcycle up in the triple clamp. And we're going to design a component that connects our steering column to our front fork of the bike. And we're going to do this in what we call a top-down design approach, where I'm going to be modeling this part in the context of the assembly and utilize synchronous technology to do that. So what I'm going to do is I want to leave the display of those parts on so that I can make sure as I'm designing this new part, the function and the fit around those existing components will be there for me. So the first thing that I want to do is I just want to tag my existing components. I know that I need to connect to the front forks as well as the steering column, and you'll notice I just simply touch on those parts and I can gain access to elements of those parts. You'll see this radial menu pop up, this circle on the screen. This gives me access to my most commonly used commands. So just from a user's perspective, what I can do is very quickly access tools without having to travel with my mouse up and down the screen. So it contains 16 of your most commonly used commands. So in this case, I may want to utilize a dimensioning command to locate or to dimension those elements that I tagged previously to those components. You'll notice that with this same dimensioning tool, I can find out the locations of these parts relative to each other. So for example, if I want to go through and see how far apart the steering column is from the front forks, I can place a dimension there and I can locate those very quickly. So we'll place a couple of dimensions out here. Maybe you get the vertical location, and then maybe we'll find out what the dimension is between the two front forks there. So I can label the location of all of that geometry. If I want to hide the background components, I can do that very easily. And then if I want to look at the sketch geometry that I've created up to this point, I can look at that all by itself. Now, typically in any design, you're going to construct some geometry for exactly what you're trying to build or what you're trying to design. And I want to go ahead and create some additional sketch geometry. I'm just going to create a couple of circles here and have those applied to my existing 2D geometry. And we'll place another one over here on the left. And then again, I may want to construct or create some additional geometry, which is going to give me the basic shape of my part. You'll notice the feedback you get on the screen when I'm touching other elements. If I'm touching it or if I'm applying some tangencies, I get nice feedback next to my cursor anytime I'm creating that geometry, letting me know where exactly I am on screen. I may want to replicate that same geometry over to the other side, so we'll utilize a typical 2D application called mirror. We'll just mirror that over to the other side. And you can see what we have up to this point. So I've got the basis of my design. If I wanted to turn those background components back on and kind of take a look at where I am, we're looking at the motorcycle from a top view, and I can see exactly what I have up to this point, and I can toggle that display on and off at will. Again, synchronous technology from a design perspective, it utilizes what we call a region approach. Now, for those of you who may be utilizing a history-based model, or you might be looking at my sketch right now and saying, you need to do a little bit more work there. You need to trim some of those extra elements to where Solid Edge or your 3D application will recognize that closed shape. Well, in Solid Edge, I don't have to do that. The system will do that work for me. So I can highlight everything automatically within a window, and Solid Edge will recognize each of those closed regions. And I purposely had some of those lines extending beyond the closed shape on purpose because I want to show you how Solid Edge will do the automatic trimming of those elements for me. The other thing that you'll notice is as I start to construct the 3D model from the 2D geometry, those dimensions automatically migrate from the 2D sketch to the 3D model, and I can drive the model now from those dimensions. And we'll do some of that here in just a few minutes. I want to go ahead and complete the rest of my design and just show you some other tools that are available. The other thing you can do too is I can actually draw directly on the model itself. So if I want to start constructing some additional geometry, and again it gives me nice feedback where I am on the screen. And I want to construct just some additional regions here for the part. And you'll notice I've divided that top face into 3 different sections. I simply want to take that middle section and just create some additional geometry. The intelligence of Solid Edge is as I pull up out of the model, it knows to add geometry. If I pull into the part, it knows to cut away geometry. So the Solid Edge is very intelligent in being able to know exactly what to do just based on my mouse position. I'm going to rotate around to the bottom of the part. What I want to do is have that same exact shape on the bottom of the part. So we'll essentially just copy what we just constructed on the top face and have it copy it automatically to the bottom. This time I want to remove material, so I'll just push that geometry in at some finite distance. Okay, let's take a look so far at where we are relative to the rest of the motorcycle. And you'll notice when I turn the rest of the parts back on, we see that we have some interference with some of the other parts. And I'll show you how you can eliminate that interference here and even check for that with some of the built-in tools. What I want to do, though, again, is just focus on the part by itself and introduce you to the term that we introduced in the beginning of the presentation called live rules. Live rules, whenever I click on a face of my part, down here at the bottom of the screen, we have what we call automatic intelligence. So Solid Edge is looking at my part right now. It's not looking at how I designed the part, but it's just looking at the model itself, and it's finding things for me automatically. If I wanted to make the width of this cutout smaller, you'll notice as I click on the face and start to drag my mouse, it's modifying other faces for me automatically. And why is it doing that? Well, what it's doing is it's seeing, for example, that the face that I selected is aligned with the face up here at the top. And it does an automatic assumption that you probably want to keep those faces aligned. What it's also doing is it's detecting that this part is symmetric. So again, it's finding the corresponding faces on the other side of the part and making the same changes dynamically. Now, if I decided as the user, I don't want to move the top portion of the model, I just want to move the cutout itself. I have full control to turn those off with a single keystroke. And in my example, I just turned off the planar live rule and just had it modify that bottom cutout automatically. And I can turn those rules on and off at will, either by clicking on the button itself or by utilizing a keyboard shortcut. So as the user, I do have full control over how this part is going to be changed. What I can also do besides utilizing this editing tool is I can also place dimensions at will on the part itself. I may want this to be a specific value. So as the engineer, I'm used to precise changes or precise dimensions, and I can type in what I want that dimension to be and have the model update accordingly. I know as designers or engineers, we're a lot more comfortable sometimes, not just by pushing and pulling, but by seeing an actual dimension on the part. So again, let's see where we are. Let's look at our design. We've eliminated that interference. What are some other things that we can do to the part? And what I'm going to do is just add some treatment features, maybe add some rounds to some of these sharp edges. And you'll notice that I can quickly go through the model. I don't have to rotate the model around to get to specific edges. I can just click right through the model and tag those to have a certain fillet or a certain radius. And I'll do the same thing up here at the top. We'll go ahead and round those and make the part look a little more aesthetically pleasing. Also, as I look at the part, And you can look at this as maybe for aesthetics, or maybe we determined that the part is not very strong the way it's currently designed. I may need to make some design changes with the model itself. And what I want to do is I want to take these vertical faces and add some taper or some draft to them. And if you think about how I constructed the model, if you look over here on the left-hand side, I have the original protrusion we created, the protrusion on the top, and then the different cutouts here in the rounds. Now, in the history-based CAD tool, if I wanted to make some modifications, I would have to determine how I constructed the part and then make my edit accordingly. Well, in my mind's eye, all I want to do is change the shape of the part. And intuitively, Solid Edge with Synchronous Technology allows us to do that just by simply selecting on those faces. I don't have to worry about the history or how I constructed it. I simply grab the faces that I'd like to modify, and again, I can utilize this tool called the steering wheel. The steering wheel allows me to snap to different elements of my part, and in this example, I want to take the torus of my steering wheel and simply rotate those faces some value. And in my case, maybe I want to put 20 degrees of taper to those faces, and make this part a little bit stronger, make it look a little more aesthetically pleasing to the eye. Now that I've done that, this cutout down here at the bottom may be a little too wide, so I can relocate that same steering wheel tool to an edge, and maybe I want to push those faces that I've selected closer to the middle. So very quickly I can now make modifications to this part by simply typing in the value and how I want those faces to be adjusted, and I've now made the change that I want, again, without having to go back into a 2D sketch and figuring out what that change or how that change needed to be applied. So I can do that very easily directly on the model itself. I can also just look and see that this hole might be a little too big, and again, I can dynamically change that to a different value right here and see how that's going to now fit around the steering column. As I turn off the background components, I'm going to rotate this model around. Again, this is a nice learning tool. With this being a racing motorcycle, I want to eliminate as much weight from this part as I can. So Solid Edge has some tools that allows me to select different faces simultaneously. And what I want to do is I actually want to take the internal material out of the part. And Solid Edge, if you look down here at the bottom of the screen, is it has a tool called Command Finder. So if you think of yourself as maybe you're a new user to Solid Edge, and I've come from another CAD application, and I know that the terminology for what I'm trying to do is maybe called shell. So I can type in the word shell, and what Solid Edge will do is it'll pull up Command Finder and say, well, in Solid Edge, this is called thin wall, and by the way, here's where it's located. So again, in learning a tool like Solid Edge, we do have built-in tools that allow you to find commonly used commands, commands from other CAD systems, and find those very easily inside of our user interface to make learning the product much simpler. A couple more things that we might want to do to our model here is, again, we can reference the assembly itself. As I rotate to look underneath the part now that I've taken that internal material out, I may decide that I want to take the boss now that's on the inside of the part and actually extend it down to where it's connected to our bearing. So very quickly I can select that, and I can have that extend automatically to reference locations of other parts, and again, just adjust my design as I see fit. At any point in time, if I want to undo any applications, I can undo very quickly, and if I want to go through and make other changes, I can do that. And again, when I extended that boss down, I went a little bit too far. I want to zoom in just a little bit and make sure that I'm connected to this top edge versus the bottom edge. And again, a nice tool available, the undo command, which you're probably used to doing in other office-type applications as well. And then the last thing here, maybe for data reuse, I want to come in here and maybe make the part a little bit stronger here on the internal. I want to maybe put some strengthening ribs there. You'll notice on the left-hand side of our screen we have a tool called Feature Library. Very handy if you've created features on other models in the past and you want to reuse those. So what I can do is find some support ribs that I used on another project. I can bring those into my new design very quickly. reposition them to my new design. And if you look here, you can see that these ribs are actually extending outside of the part. But what's nice about Solid Edge is when I say attach these to my new design, it'll conform those ribs to the new shape of my part. It does automatic trimming and extending of those ribs to fit inside of my new design. One last thing here is we'll go ahead and we'll apply some fillets to the internal of the model just to finish that out. But again, you can see how designing inside of Solid Edge natively with Synchronous Technology, it's very easy not only to create the geometry but also to manipulate and edit the geometry also. So again, we mentioned documenting the model is great from a 3D perspective. It's great for visualization. It's great to reference my other parts. But obviously we need to document this 3D model into a 2D drawing. So again, we have tools available that allow us to do this seamlessly. So right here from the model, I can say, let's create a drawing. And Solid Edge has a tool called Quick Sheet Templates. And what Quick Sheet Templates allow us to do is it allow us to take our 3D models and place them into a template where, as a company, maybe we want our drawings to look the same or to look consistently across the board. And within these templates, we can save, specific view types. Maybe we always have a front, top, and maybe a right side view, or maybe we always have a section view. So what we can do is save the models, save these templates, and then with the click of a button, have these views automatically placed inside of a 2D drawing template. You'll also notice that we can extract dimensional information from the model into the drawing and save ourselves some time without having to reapply those same dimensions. I can create other views. Maybe I want to create an auxiliary view for this drawing, and just by simply clicking on that bottom view, I can now drag off an auxiliary view and do some other applications here. Maybe I want to crop the view because I don't need to see the whole thing. So we can go ahead and crop that, maybe move it to a different position on the view itself. I may also want to apply some dimensions to this. So the same dimensioning tools that we found in our 3D application are also found inside of our 2D drawing application. So as the user, you're not learning different command sets. You're using the same tools both in 3D as you are in 2D from a dimensioning perspective. This Smart Dimension tool allows me to click on different elements, whether it's a line, gives me a linear dimension, a radius, a radial dimension, or maybe if I wanted to click two different elements, I can also get an angular dimension from that as well. Detail view, for example, I may want to blow up and maybe get a little bit more detail of our rib structure. Again, with 2 clicks of the mouse, I can get a nice detail view of that area of the model and maybe detail that in a little bit more finer detail so that I can get the thickness of the ribs and maybe what those radius values are. But again, just wanted to show you how quick it was to go from 3D model to 2D drawing. And again, in a matter of minutes, we've created a nice documented detailed drawing of that part. I'm going to come back to the assembly file, and what we're going to do next is we're going to focus on the back end of the motorcycle. And we're going to switch gears a little bit from designing natively inside of Solid Edge and show you how you can reuse data that was maybe brought in from a supplier or a vendor and it was created in another CAD tool. So if you look towards the back of the bike, we have a shock absorber, we have our swing arm here in the back, and then we also have the frame. And I need to use a connecting mechanism to connect these components together. And I know that my supplier uses a different CAD tool, but I want to go ahead and utilize his components inside of my design. In Solid Edge, when I go to a file open, you'll notice that Solid Edge is able to open natively many different types of file formats from many different CAD systems. So towards the top of the list is our native Solid Edge documents, assemblies, sheet metal components. As you look down the list, we also notice we can open up some of the neutral file formats such as Parasolid, Step, IGES. And then as you look throughout the list, you'll see a listing of other CAD applications and how Solid Edge is able to open up not only their individual part documents, but also their assembly files as well. I'm going to pick a representation from another CAD tool, and we're going to go through and show you how we can open up those files directly. So in this example, we're utilizing a SolidWorks assembly, and I'm just going to open that up directly inside of Solid Edge. This is going to be the mechanism we're going to use. As I rotate the model around, again, you'll see we've got different components. So as we open up the assembly file, all of the individual part files and subassembly structures are going to come across into Solid Edge if you look over here on the left-hand side. What I may want to do just for visualization purposes is I may want to go through and modify the look of this part. Maybe I want to make it look a little bit more realistic. So I'm going to change those to an aluminum type of rendering. And maybe for the hardware, I'm going to take the bolt and take this nut and maybe change those to maybe a steel. So again, I can change those very quickly and just make the parts look a little bit more realistic. Now, for those of you who maybe have been in this type of situation, we're going to look at this from a couple of different perspectives. Before we do that, though, let's go ahead and save these files to disk. And we're going to look at this from both the single part application as well as the assembly. So let's focus first on the single part. So for any of you who have ever brought in documentation from another CAD system, you've probably seen something like this, where we don't have a list of features that we're able to utilize to make modifications to this part. We simply have what we call a body feature, and what the industry calls a dumb solid. It's designed the way it was in its original CAD tool, but when it comes across into another CAD system, we don't have the ability to read across the intelligence that was built in originally. So sometimes if you need to make changes to this part, you got to do it in a very creative way. So let's say, as an example, I needed to change the boss width of this part. What you would typically do in a history-based system is you would come in and essentially build features on top of the dumb solid. So as an example, I would come into my modeling tools, I would select a reference plane, and then I would start to draw my shape. So maybe in this case I want to draw a shape or a sketch here, or maybe I'm including geometry off of the dumb solid. So basically building in additional features to make these changes. So maybe I want to make that boss a little bit wider. But inherently, you're noticing that I still have to create 2D sketches, and the model is based off of those 2D sketches. So if I needed to go back and change that downstream, I got to go back to the 2D sketch, make a change to it, or make a change to any dimensional information, maybe to change the width of the boss, or if I wanted to change the diameter of that cutout, I can do that with sketches. Now, for this example, not that big of a deal, but if you think about having to make other types of changes, maybe if I needed to change the spread length between these two holes, I'm actually going to have to do a lot more work. Maybe eliminate the boss here, change the entire length of the part, and then add that boss in. And I would be creating a lot more of these types of features manually. So if you think about how many changes and what the change actually is, this could be a long, tedious process. I'm going to delete what I just did and take the part back to its original condition and just show you what Solid Edge is able to do right out of the box. So what Solid Edge can do is when I click on a face of the part, again, we did this exact same thing in the native part that we created from scratch in Solid Edge, but we don't care whether the part is a native Solid Edge part or if it was brought in from another CAD system. We utilize the same editing approach. So if I click on that boss, what Solid Edge does for me automatically is it's going to change all three bosses simultaneously. And it does that because, again, the live rules is saying, hey, these bosses are the same width. You probably want them to stay the same width. Again, as the user, I can hit those nice keyboard shortcuts. If I turn off the alignments of the planes, I can turn those off. Or if I want to turn off symmetry in the part, you'll notice as the user, I have full control over the exact result that I want. So again, just by turning on and off those live rules, I can very quickly make those modifications without having to create the 2D sketch geometry. Or as another example, if I wanted to maybe change the distance between those holes, I simply click on the hole itself, and notice how Solid Edge, again, is modifying the boss on the top. It's finding the symmetry in the part. It's making that change for me because of the automatic intelligence that's built in utilizing synchronous technology. So again, just wanted to show you whether the part is brought in from another CAD system or native, we utilize the same tools from an editing perspective. In the same regard, I can come in and automatically place 3D dimensions on this imported part and modify it with dimensional information. So I have control with the push and pull method, or if I want to be more precise with dimensions, I can apply those same dimensions to the model itself, regardless of how it was built in the first place. And again, I can show you that same type of change here with the dimension. All right, I'm going to delete those dimensions, and I'm going to come back in just a few minutes and show you how we can automate the parameterization process. And by that I mean applying the dimensional parameters to the model. So let's come back to the assembly. So we think about part models in one way, and then when these parts are involved in an assembly, we have to think about some other applications. So we can make the same types of edits right here at the assembly level. So again, if I were to click on that boss and start to adjust it, you would think, based on the relationships between the bearings that are inside of this part, that they're going to come along for the ride. Well, you'll notice that by default, just like we don't bring across features in a single part, we also don't bring across automatically the intelligence of the assembly with assembly constraints. So what I can do with Solid Edge is I can take, for example, all 6 of the bearings that reside inside of our housing here, and I can tell Solid Edge to apply those constraints automatically. So what I'm going to do is say, let's look at the 6 bearings and look how they're positioned in my housing. And what I want you to do is to find any mating conditions or alignments, or if they're aligned within the hole, go ahead and find those automatically. And what you'll notice is as soon as I click process, automatically it finds all of that information for me. I can accept that, and now I have built-in assembly constraints for each of those components. So just to show you that, if I click on the housing, it's applied all of the relationships to each of the bearings. And same thing, if I click on any of the bearings, you'll see how it's applied that relationship automatically. So what does that mean? If I now adjust the boss, notice how the bearing now comes along for the ride. Or if I modified it in this direction, notice how it's going to stay with it inside of the hole. So I can make these changes very quickly now because of those intelligent assembly constraints. I'm going to do something very similar on these other parts. Let's just show those parts by themselves for a second. And we'll do something very similar where we'll come in and say, let's just look at these parts by themselves. And again, let's apply those same constraints. Find anything, any mating conditions, alignments, and we'll process those. And again, very quickly we can have those applied. Let's show the rest of the assembly. You can also, as the designer, go through and make these same changes manually. So let's say I want to connect the housing to our arm. And what I can do is with our assemble tool say, well, let's make sure that the boss here stays aligned with the boss and the arm. And I want to make sure that the housing stays centered between the ears of the extension arm as well. So we have a relationship that allows us to do that very easily as well. So I'm going to say, let's take these 2 faces and let's make sure they stay centered with those 2 faces. And that'll help us apply that intelligence between those 2 components. Okay, so again, I mentioned manually placing parameters on the parts themselves, having Solid Edge go through and also apply intelligence to assemblies. I also want to go through and show you how typically when you're working with a 3D CAD system, you may also have access to the associated 2D drawing. So again, from a 2D perspective, we can bring across the 2D drawing of that 3D model. And the 2D drawing has all of the manufacturing information built into it. And what I can do inside of Solid Edge is if I didn't have the 3D model, I can utilize this to create the 3D model very quickly. Or if I have both the drawing and the 3D model, I have a tool that allows me to essentially marry those two together. So this is a tool called Create 3D. And because I have that part already, I'm going to go ahead and select it here in the list. And what I'm going to do is now select all of the information in the drawing. And you'll see what this is going to do is I can tell it to bring all of this 2D information into the model itself. And what it does is it opens up my part with this information. So now what you'll notice is as I look at different views, notice how all of the manufacturing information from the drawing gets applied to the 3D model. And what I can do is say attach the drawing dimensions to the part model. And those will jump from the 2D sketch onto the part. And if you don't believe me, I'm going to go ahead now and delete those 2D sketch dimensions to where we're just now left with the 3D model. And you'll see that those dimensions have now been applied automatically to the part. Other types of intelligence you can add as the user is I can come in at any time and add 3D modeling constraints. The history-based CAD user is used to doing this inside of a 2D sketch, but what I can do inside of the 3D model is apply constraints directly to the model. And I'm just telling Solid Edge, let's apply a 4mm offset to those faces. I want to maintain those values. And we'll do the same thing over here. And we'll apply that same offset. Well, what does that do for us? Well, if I look over here, I can apply those and see those graphically, and if I ever wanted to make changes to those, you'll notice how Solid Edge will automatically make those modifications, in this case maybe to the thickness of the thickness of our housing. One more thing I may want to do is maybe just finish the detail of this part. I may want to round some of these edges. So again, I can window select around the entire model. Maybe I want to deselect the whole dimensions. And let's do that one more time. I got a little bit too fast there with my selection. Let's grab all of those and let's deselect the 3 boss holes. And then the last thing here, we'll take maybe a chamfer and apply a chamfer to the boss holes. So we've completed the model itself. We'll save this. And what you'll notice too is when I come back to the assembly now has those same exact changes been applied. So you'll see now all of the radius values have been applied, the chamfers to the holes in the boss. And where this becomes very handy for me is now that I've added some of this intelligence back in, if I need to make changes to the part, right here at the assembly level, I simply select the faces of my part, and you'll notice that I can now go through and start making any design changes. Maybe I want to change this dimension from 60 to 75. You'll notice all of the intelligence, the bearings are going along for the ride. You'll notice also I can tell Solid Edge which side I want to move. I want to push that out to the right. Maybe I want to change this dimension, maybe push it down just a little bit. And again, I can tell Solid Edge which boss I want to move. I have full control over that as the designer. One last thing here is I may want to come in and also make some changes to the arm, this link arm, which is going to link to the swing arm of the motorcycle. I may have noticed that this cutout here is not serving any purpose. Yes, it's eliminating some weight, but I need to have that for the strength of the part. So right here, even though this part has been imported, I don't really have an actual cutout feature to recognize. So I can have Solid Edge do that for me automatically. I simply select that face and say recognize that as a cutout. And what that gives me the ability to do right here from the assembly is I can now delete that cutout and add that material back in for strength. The other thing I may want to do too is do some other parameter recognition. So as I go into this, the arm of the part here, You'll notice right now I have counterboard holes. I may want to recognize those as parameterized features. So I can say recognize those holes. I don't want them to be counterbores. Maybe I want to change them to just a simple hole. So I can change these parameters on the fly and have them make modifications to the part. Same thing here is I may want to apply some dimensions to this part. And I could do that very easily as well. Let's maybe hide that screw so I can access the hole a little bit easier. And I can apply those dimensions very quickly. So again, if I needed to lengthen the arm, I can very easily just select the body itself and say, well, I don't want that to be 75. I actually want that to be 80. And I can lengthen the arm and still maintain the connection to the other components without affecting anything on the housing or the bearings. So we've made different design changes here. We're going to go ahead and save those changes, and let's go back to our motorcycle and see how we can apply that to these components here. So I'm going to come in, I'm going to grab our design here. We'll just grab it and we'll bring it into the assembly from our library. So you'll see over here in the library, everything that we've done up to this point can be accessed here. I'm just going to drag our design into the assembly file itself. It's very easy to constrain. So again, I've got my 3 connection points. I simply just say, let's align the boss here to these components. And we'll apply some different mating conditions. Maybe I want to put in a 3 mm offset between these components here. So we'll do that. And then the last thing we'll do is we'll connect down here to the swing arm. So the first thing I want to draw your attention to is I'm sure for those of you who are doing engineering or design work, you've probably never seen this before, right? Where you have interference. And we have some great interference detection tools allow us to check or gauge if there is any interference. But in Solid Edge, when I do run across this situation, we have some tools that I can use right here at the assembly level. So one of the things I may want to do is I need to see what is the actual width of our connecting feature here. So as I rotate around and I find the edge, what is the width? And it looks like it's 50 millimeters. And so I need the spread distance in my mounting arm on the internal to be at least that value, probably a little bit more for clearance purposes. So what I want to draw your attention to is right here at the assembly level is I can make a change to my mounting arm. And again, I'll go to my dimensioning tools. And what I can do is I can say, let's add some additional dimensions. Maybe we didn't have these initially. So let's place a dimension maybe on that ear. And we want to maintain that dimension. But also, let's place a dimension between these 2 locations. And you'll see that that's 40. And that's where the interference is coming from, is that's not wide enough. So right here, after placing that dimension, is I can come in and I can make changes to that value to eliminate that interference. So maybe I need it to be maybe 52 and put a millimeter clearance on either side. And right here from the top level assembly, I've made those changes. Now, by changing the width to eliminate that interference, I've got a lot of slop now between our mounting arm and our housing here for the bearings. So again, I can come in at any point in time, and maybe this time if I wanted to apply a dimension I could, or if I just want to use the steering wheel application, I can do that as well. But again, I can come in and say let's extend that boss so that it fits a little bit better inside of our mounting arm. Finally, just to finish out the design, I need to connect to our shock absorber. So I can very easily go through and do that. And basically, we'll just finish out the rest of the application by saying, let's assemble the boss here to our shock absorber and have it adjust those components to where now they fit properly. So again, just being able to go through very easily to not only design components natively inside of Solid Edge, but also be able to come through and make other design changes on the fly with imported components that were brought in from other CAD systems. You can see how Solid Edge allows us to very quickly make those changes. I mentioned interference before, and I can see just graphically we may have some interference here. And just to double check, let me grab these two parts. And what you'll notice here is Solid Edge shows me that there is some interference in those two parts, and I may need to go through and make some changes to that. So again, just to show the flexibility of the tool, I can very easily come in at any point in time and make those changes just by clicking on the dimension and maybe changing the dimension right here at the assembly level. And now you'll see that if we check these two components now there's no more interference. So in a matter of seconds, I've made those modifications to these components. I know we're running up to the top of the hour. I want to make sure that we have time to answer any questions, but I hope you enjoyed just some of the tools that are available in working with Solid Edge, being able to design natively in 3D, as well as bringing in those components from other CAD systems, and how easy it is to work with that data, make modifications, and make it work for your particular design. I guess before we open it up for Q&A, the last thing that I may want to do also is just get a nice bill of materials for everything we've done so far. And again, you'll notice Solid Edge allows us to very quickly document all the components, does a nice job of automatically ballooning all of those parts and allowing us to get any information out that we need relative to the name of the part or how many might be involved in this assembly, and it documents all that with both a parts list as well as a nice balloon set as well. So what I'm going to do is I'm going to turn it back over to Kevin, and we'll open up the line for any Q&A.
Well, so let's keep it on your screen for now. Very cool demo of features in Solid Edge. I have a few questions here. Maybe take a minute or two to answer them. Let's see. I have one question. Can you briefly describe some benefits of synchronous technology over feature recognition or direct editing? Kevin?
Okay, yeah, sure. So, okay, if you're talking about feature recognition, so there are some tools out there that some of the other CAD systems utilize that basically what they'll do is they'll look at the 3D model and they'll quote-unquote recognize features by rebuilding sketch geometry to create features. So this could add potentially some intelligence to the model, and you can edit some of those features, but the bottom line is they're still history-based, and it creates essentially the same type of overhead in the model to where it's still reliant on the order of the history of the parameters, and as you make changes, it still has to recalculate, and it's not as quick as synchronous technology. I think direct editing is a little bit different than feature recognition. So direct editing doesn't actually build intelligence into the model. What it does is it just it makes changes to the boundary of the model. So there's tools like move face, for example, but the end result is it's still a dumb solid with no intelligent features. I think as we saw today, synchronous technology is a little bit different. It actually, whether you're modeling the part natively or bringing in those components, you saw me add intelligence with 3D modeling constraints. You also saw me add intelligence with dimensional information. So we have a lot more control, and you'll notice, or you've noticed today, that the changes are much faster.
Very cool. Okay, so I have another question here. This is from Antonio.
Any other questions?
Yeah, I have a question here from Antonio. He wants to know, could you give a bit more information about surface modeling with Solid Edge?
Sure. So Solid Edge also has some built-in tools for surfacing, and we utilize a lot of industry-related surfacing tools. And depending on what you're trying to model, but we have those tools built in. So, you know, constructing cross sections and guide curves, and constructing surfaces between those, and you know, Solid Edge has a lot of great tools available for surfacing for those types of applications. Without getting into specifics, I didn't know if there was any specifics you're looking for, but surfacing tools do come built into the software.
How does this distance you from the competition? Do you expect your competitors to offer something similar in the near future?
I think I think we believe we have a lead based on our competition. Synchronous Technology has been around since 2008. We are this summer coming out with our 7th iteration of Synchronous Technology. So I think just by watching some of the applications we've done today, we have basically 6 years of experience behind us and allowing us to continuously evolve and develop these tools. So I think from a competition standpoint, we feel like we're way ahead of the game.
Sounds good. This is not a question, but I guess Ben wants to know whether or not a surfacing webinar is in the future. And you know what? Now that you brought that up, I'll definitely work with Kevin and the team at Siemens to maybe set one up. So, yeah, that would be cool.
Absolutely. Yep.
Sounds good. All right. So, Kevin, I will take back the podium and the microphone here. Cool. And we're going to start wrapping up. I just want to mention that if any of our attendees or our viewers out there on YouTube and the recording, if you guys have any other questions about Solid Edge and what it can do for you, definitely email me at Kevin@Novedge, and you can also contact our specialist at Calvin that's Calvin. It sounds kind of similar, Calvin, Kevin, but it's Calvin with a CALVIN at Novedge.com, and we'll work with Kevin to get these questions answered. But yeah, thank you for attending. I want to let everybody know that if you guys are looking up Solid Edge and want to learn more about its features, definitely head on over to Novedge.com. We are one of the largest online resellers for design software and offer a whole range of design tools that are basically good for any designer, including those who want to interested in using Solid Edge. So if you want to learn more about it, contact Calvin at Novedge.com. And Barbara?
Yes, that was a great presentation, Kevin. I'm here to also remind you to visit the Novedge blog. And if 3D CAD is your thing, you can look at our categories on our webpage, the blog page, and find the blog post right for you. This week, for instance, we interviewed the design engineer at Human Scale, the leading manufacturer of ergonomic products for the workplace. Or just like us on Facebook and get all the blog posts, and you might find something that interests you. There's always something new, some great stories, and very inspiring interviews. And to catch up also with our next webinar, you can visit our website. And coming up next week, how well does Maxwell Render's plugin perform in an actual design workflow? Working architect Francois Verhoeven joins us to demonstrate the modeling and visualization process with SketchUp 2014 and Maxwell Render Suite V3. The presentation is free and will last about 1 hour, including the Q&A session. To sign up, head on over to www.novedge.com/webinar/113. Last but not least, today's webinar is being recorded live, and if you want to rewatch episode 112, as always, you can find it on our Novedge webinar series channel through Vimeo and YouTube. Now, Kevin's.
All right, so I do want to mention, yeah, head on over, check us out on Facebook. We should have the recording up by today's end. Kevin, I think next time we do this webinar thing, I might have to come up with a nickname for myself. So just to make sure that we're all on the same page and not too confused. But yeah, thank you again for joining us. Kevin, have a good one. Bye, everybody.
You too. Thanks.